Welcome to the presentation based on the research called Determining the Importance of Factors in the Selection of Immersive Technology for Artworks Reproduction, prepared by Oleksandr Tymchenko, Olha Sosnovska, Orest Khamula, Svitlana Vasiuta, Solomiya Dorosh, and Olha Lukovska. In today's rapidly evolving world, we are transitioning from informatization to digitalization, marking a new phase in the development of modern information technologies. The swift progress of information, communication, and digital technologies has underscored the growing significance of immersive technologies. In the realm of art, a noticeable trend in recent years is the active shift towards virtualization. One of the reasons was a certain curiosity, the idea of creating a new artistic transmitting platform and attracting more attention. Navigating such a large flow of information became difficult, so they began to create a structured platform for presenting art and cultural objects online. Museums and galleries have contributed to the development of the infrastructure of the online cultural market and brought some logic to the chaos created in the Internet. The main information technologies commonly used by most art institutions and artists today are augmented reality and virtual reality, which offer a wide range of possibilities to implement their ideas. A crucial prerequisite for adopting augmented reality technologies is the feasibility of implementation and access to the necessary technological resources. This encompasses the availability of appropriate equipment, established procedures, and compliance with the conditions and methods of their use. The authors state that nowadays the traditional way of holding exhibitions may not always be possible, and now this problem is particularly relevant. Human activity has moved more from the physical environment to the digital side. Therefore, nowadays many museums are forced to implement computer technologies to attract new visitors and increase interest. Another problem that museums face is that some objects of exposition can have extraordinary dimensions, be very small, and over time they can also be destroyed. Therefore, as the authors note, the mobile application can be used as a platform for digital exhibitions. At the same time, it is obvious that research data and applications on the use of immersive technologies are quite rare, so in our opinion, they need more study. The analytic hierarchy process is a systematic approach to decision-making that allows to formulate and evaluate complex problems, compare different alternatives, and determine their priority based on the importance of different criteria and sub-criteria. Proposed by the mathematician Thomas Sadi, the method has gained popularity due to its suitability for solving a variety of problems in management, economics, engineering, scientific research, and more. The main tool that helps to do this is pairwise comparison matrices. A pairwise comparison matrix shows the relative importance of one criterion or alternative compared to others. The relative importance is expressed in numerical rating that the expert assigns to each element relative to the others. The evaluation can be positive or negative. Usually, a scale is used for evaluation which can be numerical or textual. Thus, the analytic hierarchy process allows experts to reveal their preferences and relationships between the elements of the analyzed system. As previously indicated, the analytic hierarchy process enables the systematic organization and quantification of diverse elements within intricate and extensive issues. This in turn aids in facilitating improved decision-making through the utilization of expert evaluations and thorough analysis. The task of determining the influencing factors on the selection of augmented reality implementation technology for the artwork reproduction will be performed. Let the set of factors be the set I equals the set containing the elements 1, 2, 3, and so on. Let's select a subset of most significant factors from them. For clarity, let's assign each a number: G1 commerciality, G2 cross-platform software, G3 hardware, G4 external environment, G5 type of markers, G6 access to the Internet. The next step is construction of a graph of connections between influencing factors shown on this slide. Based on the graph of connections, a binary dependency matrix B is constructed for the set of vertices G1 as follows. Using the matrix dependency B, the reachability matrix is constructed. Its construction entails the creation of table 2. Binary elements are determined according to the following rule. The vertex Gi is called reached from the vertex Gj if there is a path from Gj to Gi in the directed graph. The subset of reached vertices is denoted by Rgi. The vertex Gj is called a predecessor of the vertex Gi if there is a reach of Gi from Gj. The subset of predecessor vertices is denoted by Agi. The intersection of subsets of reached vertices and predecessor vertices will be the subset. The set of vertices for which the specified unreachability condition is performed can be determined as a hierarchy level. Table 3 is formed with the elements Gi, Rgi, Agi, and Rgi intersection Agi. For its formation, the numbers of the elements that have 1 are written out from the ith row of the reachability matrix. To form the subset Agi, the numbers of elements that have units are written out from the ith column of the reachability matrix. The subset Rgi intersection Agi is formed as the logical intersection of the elements of the subset Rgi and Agi. As it can be seen from the table 3, in the first iteration the equality Agi equals Rgi intersection Agi is performed for elements 1, 4, and 6. These numbers represent the factors of commerciality, external environment, and access to the Internet. The rows with the numbers 1, 4, and 6 are excluded from table 3, and in the second column the numbers 1, 4, and 6 are removed. Thus, the data for the second iteration is received. Similarly, the following iteration levels are determined in table 4 and 5. Based on the results of previous calculations, we construct a hierarchical model for determining the priority of the influences between the factors of selection of augmented reality implementation technology for the artwork reproduction. As a result of solving the problem of determining the influencing factors affecting the choice of augmented reality implementation technology for the artwork reproduction, a well-structured hierarchical model has been developed. This model clearly demonstrates the prioritization of the factors under consideration. Notably, the crucial determinants in the selection process of augmented reality implementation technology include the type of markers and cross-platform software. Evidently, the application of the analytic hierarchy process yields favorable outcomes in addressing complex processes that are difficult to describe in the form of mathematical units. Consequently, employing this process facilitates a comprehensive evaluation and prioritization of the factors influencing the selection of augmented reality technology for artwork reproduction. The research findings serve as a fundamental groundwork for subsequent studies, enabling the validation of the accuracy of the results obtained. Thank you for your attention.